The Iterator Design Pattern by myself, Tristan Whitus. The Iterator Design Pattern, we're going to go over 7 different slides here in regards to the Iterator Design Pattern: an overview, an intent, motivation, structure, consequences, known uses, and then a summary of the application that I've built for the Iterator Design Pattern. Overview. So the type of design pattern that the iterator is a behavioral pattern, which means that it's a design pattern that is concerned with algorithms and the assignment of responsibilities between objects. It's very common in Java and the .NET programming environments, used as a way to get access to certain elements of a collection in a very sequential manner without needing to know its underlying representation in data. 3 key points here for the intent of the pattern: to provide an object which traverses an aggregate structure, abstracting away assumptions about the implementation of that structure. So kind of like a dynamic list. Extract the traversal behavior of a collection to a separate object called an iterator. The iterator object encapsulates all the traversal details, such as current position and how many elements are left until the end. The motivation of the iterator pattern: when your collection has a very complex data structure but you want to hide its complexity from clients. Very helpful for convenience or for security reasons. It allows kind of a more abstract and dynamic way to iterate through a list of objects as opposed to a list, and needing to know exact indexes. So the basic structure of the iterator pattern is we have our iterator interface, which declares the operations required for traversing a collection, such as getting next element, getting current position, restarting the iteration. We have the concrete iterators, which implement specific algorithms for traversing a collection. The iterator object should track the traversal progress on its own. The collection interface declares methods for getting iterators compatible with the collection. The return type of the methods must be declared as the iterator interface so that the concrete collections can return different types of iterators. The concrete collections returns new instances of a given concrete iterator class each time it's requested by the client. And then the client, of course, works with both the collections, classes, and iterators via their interfaces. Consequences. So the consequences of the iterator design pattern allow the client to simply use methods such as like a next, a previous, and last, for instance, to simply navigate through a list without needing to know exact indexes or the data structures in the background. This can make very complex data structures be easily accessed by the client. Some known uses: clicking next or previous on social media profiles, card games, which is what I actually did my application on, such as euchre, poker, where there's only a set amount of cards, and you can iterate through the deck using this design pattern. It's very common in complex data structures such as binary trees. A list of notifications on a social media platform, for instance, television channels, and a to-do list application, and then just quite generally applications that require lists of complex data structures. In my application, just a high-level overview will be a euchre card shuffler. Shuffles user 5 cards from a set collection of cards in euchre card game, designed to skip every fourth card to emulate proper distribution of cards. If user already has 5 cards, then the dealing stops. Okay, so just a quick overview of my application here. We have our main method. The collection is built here. An iterator instance is created here. And some more of my main functionality that I'll come back to. This is my item class. It's just basically an item that's added to the collection. You have your constructor and then your get for the name. We have our collection interface. declares methods for getting iterators compatible with collection. So the return type's iterator, create iterator. Um, and we have our concrete collections, returns new instance of given concrete iterator. Um, so it's going to get our count um, of the collection and return its um, specific index. We have our iterator interface here, declares operations required for traversing a collection. Here we have our first, our next, our is complete, and current item. We have our concrete iterators, which implement specific algorithms. Um, so again, we have our first, our next. Here we have our set our step size. So if we wanted to skip every first, we would set this value step to 1 here, but I'm have it set for 4 because it's a 4-player game. Um, and then max cards per hand. This is another method that prevents a user from getting more than 5 cards. Um, and we have our gets current item, and then whether or not the current is greater than or equal to the count here. So just a quick step through here. So we build our collection here. And if you wanted to go one step further in randomizing the cards added, you could just simply create another method um, randomizing that uh, push onto the collection object there. We're going to create our iterator instance. Okay, here we're going to start iterating over the deck. So here, as you can see, it's different than a for loop in that we're using iterator.first to access the first element as opposed to some commonly used functionality there would be like int I equals 0, but we're going to use a dot first method, and then while the iterator is not complete, go to the next item in the collection. Okay, so here we get our ace of spades. Here we get our 10 of spades. Here we get our queen of clubs, so we should only get 2 more cards here. Ace of hearts. Okay. Maximum card per hand equals 5. We can get one more here. Yep. And here we should hit our else statement, and it's going to tell us that we have a full euchre hand. So that is an example of the iterator design pattern. Thank you.